Kirchhoff's law. Now first law is Kirchhoff's current law. The algebraic sum of currents meeting at a point or junction at a junction in an electric circuit is 0. So summation of current is 0. Now here two types of currents are there. Two types of currents are there. One is entering the junction and other is leaving the junction. So here sign convention here. We have assumed here current entering positive and current leaving negative. So if this kind of figure is there, I1, I2, I3, I4, I5, I6. So this will be algebraic sum, means plus minus, entering plus or leaving minus. So I1 minus I2 minus I3 plus I4 minus I5. This I5 is leaving, that's why minus. So this will be I1 plus I4 equals to this one. Now second law is Kirchhoff's voltage law. This is also known as KVL. So in a closed loop, closed loop of an electric circuit, the sum of EMFs is equal to the sum of product of resistances and the current flowing through them. So on the left side summation of EMFs, on the right side summation of voltage drop across resistances, which is I into R. Now here we have to consider sign convention. For left side we have sign convention here. When we are moving from plus to minus, that means there is drop in potential, there is drop in potential. So this is taken as minus E. So when we are moving in this direction, in this manner, from minus to plus, that means there is a rise in potential. So potential is increased. So this is taken as plus E. So one is rise, other is drop. So for drop in potential minus, for rise in potential plus. So for the right side, we have to consider two directions here. First one is when we are moving along the direction of current direction, then IR drop is taken as positive. And second part, when we are moving against the direction, current direction, it is taken as minus. Here in this loop, let us check. In this figure, let us check A, B, C, D, A. So we are moving like A, B, C, D, A. So this is the direction we are moving from A to B, B to C, C to D, D to A. So by Ohm's law, this is summation on the left side, summation of EMFs, and on the right side, summation of IR. First of all, let us check E. So from here, E1 is here. So we are moving from minus to plus. That means there is rise in potential. We are going from negative to positive, that means rise in potential. So this E1 is taken as positive E1. Now from B to C, there is also another potential. Here also we are moving from plus to minus. So there is drop in potential. So this is taken as minus E2. So no other EMFs are there. Now on the right side, first is this is I into R1, and we are moving in this direction from A to B. So we are moving in the direction of current. So this is current direction, and also we are moving in the same direction. So loop direction and current direction is same, that's why it is taken as positive. And here this is current direction, and also we are moving in the same direction. So this is IR drop, that is I into R2 will be is taken as IR2 positive. This positive value here. This is positive, and in a similar manner IR3, IR4, they are all in same direction. If opposite, they will be taken as minus. Now let us solve some problems. This is number one problem. A copper wire of resistivity rho and resistance capital R equals to 10 ohm is stretched so that its length becomes 3 times, and assuming there is no change in its density on stretching, calculate its new resistance and resistivity. So given 10 ohm resistance and density is constant, so no change in density. So before stretching, what is the value by Ohm's law? R equals to rho L by A. So after stretching, so density, this is density 1, density 2. After stretching, they are same. So this is density. So mass per unit volume, so mass cancel. So V1 is equal to volume 1 is equal to volume 2. So density constant, volume 1 is equal to volume 2. Now we have V1, V2, this is area into length. Volume is here, suppose new area is suppose A dash and length is L dash. Here this is AL and new area is constant, and this is length is changed. Length is 3 times. Yes. So length is changed by 3 times. And area also is changed by 3 times as given in the question. So length becomes 3 times, area becomes A by 3 here. So density is constant here, so volume is also constant. So therefore if length, so their product must be same. So therefore here, now suppose this is expression for new resistance, which is R dash. So rho has not changed, resistivity has not changed. So L dash, so A dash here is reduced by A by 3. Now here so this is 3 times L and area is reduced by 3, A by 3. So total value will be 9 into rho LA. So this is value of R. So this is 9 into R. R is given as 10 ohm. So new resistance will be R dash will be 90 ohm. And there is no change in rho resistivity. A wire of uniform cross section length L has a resistance of 16 ohm. It's cut into 4 equal parts. Each part is stretched uniformly to the length L. All 4 stretched parts are joined in parallel. Calculate the total resistance. Assume density remains the same. So here also R1 is given 16 ohm, A1 is given A, L1 is given L. So after cutting, L2 will be L by 4 reduced to 1 by 4. So area 2, so area is not changed. Area has no change, so area is same. Here R2 will be R1 by 4, that is 4 ohm. Now each part is stretched to L. So L3 is now equal to L. So in the third part, they are stretched to length L. What but density remains same, therefore volume is same. So A2L2 equals to A3L3. So A2L2 is L by 4. A2 has not changed, area has not changed. This is L has L2 has changed, L by 4, and this is L3 after stretching. So this is become L, and this is A3. So A3 we have calculated from here, which is A by 4. So this is R2. R2 equal to rho L2 by A2. So this is R1 by 4. R2 equal to R1 by 4. From here 4. This is R3. R3 is rho L3 by A3. L3 by A3. So L3 is L and area 3 is A by 4. Now rho 4 times rho L by A. So this is R1. 4 into 16 is 64. Now these are connected in parallel. All parts are connected in parallel. Total resistance will be 1 by R3, 1 by R2, 1 by R3, 1 by R2 equals to 1 by total R. So this will be 1 by 16, finally 16 ohm. So its total value will be 16 ohm, total value. Now this is example number. A voltmeter V of resistance 400 ohm used to measure potential difference across a 100 ohm resistor in circuit as shown in figure. So this potential difference, this voltmeter is used to measure 100 ohm resistance. Supply voltage here is 84, this is 200 resistance, this is I given here in the figure. Now what is the reading of voltmeter? Calculate the potential difference across 100 ohm resistor before voltmeter is connected. So here given data are voltmeter resistance is given 400 ohm and supply voltage is 84. So small r and capital R, they are in parallel. Here small r, the voltmeter, internal resistance of voltmeter will be in parallel with 100 ohm. So its value will be, after combining calculation, we will get 80 ohm. So equivalent resistance will be 80 plus 280. Equivalent resistance will be 80 plus 200, which is 280 in the figure. This will be 80 and plus 200, so 280. So current is source voltage by equivalent resistance, which is 280 by 484, so 0.3 ampere. Voltage measured by voltmeter. Now we know the value of current now. So voltage measured by voltmeter will be, current is 3 by 10, and what is this, 80 ohm. So it will give the potential difference combining two resistance, internal resistance plus 100 ohm, which is 80. So voltage reading given by is 24. Before connection voltmeter, so before connection there is no internal resistance, total internal resistance, no internal resistance, so resistance will be 100 plus 200, 300. So current is source voltage by total, which is 84 by 300. So voltage across 100 ohm will be current into resistance, which is voltage is, current is 84 by 300, this is 100. So finally 28 volt. Now next question, a battery of EMF E and internal resistance R gives current of 0.5 with external resistance 12 and a current of 0.25 with external resistor 25. Calculate EMF and internal resistance of the cell. Now here, case 1, external resistance is this and current is 0.5, it is given. From here we have the relation of the cell is, this is EMF by capital R plus small r. So this is given here, this is also given, so small r is not given. So this is equation number 1. This is number 1 equation. Now in the second case, in external is 25 and current is 0.25. Now using the same expression here, we will get E equals to this one, second equation. Now we want to find out the value of these two. So solving these two, we will get this is R, small r equal to 1 and E equals to 6.25. 1 ohm, 6.25. So this is answer. EMF and internal resistance is 1 ohm.